We have already started the collection framework in the last session, and few parts of the collection framework we have already seen. We have seen the linked list, how to create the linked list data structure, which is a linear data structure which uses pointers. Okay, so now today we are going to see basically the vector part and stack part. So how the vector and stack works. I'm sharing my screen. So in the vector is also known as legacy class. We can use a vector for storing the data. Whatever the methods we have seen of the list interface and the collection interface, we can use all those. Apart from that, as it is a legacy class, it has two more new methods for adding any element, add element and insert element. You can use it for adding any element into the vector. As well as this is vector related, you can use every same method types. Okay, you don't have to use any other method types apart from that which we have used for removing, iterating over any list. Okay, you can use all those as it is. Only the few more methods are there in the vector class apart from the collection interface methods. Okay. Then stack. Stack is a basically child of vector class. It is a class models that implements stack data structure. It works on the principle of last in, first out. So whatever the data goes into the last, that should go come out first. Okay. So it uses the stack data structure, last in, first out order. It is a subclass of vector, and we can use, apart from the collection interfaces methods and vector methods, you can use two more methods for performing insert and remove operations. That is a push and pop. Okay. So each and every implementation class will have the same method. So I'm not going to explain the methods again and again. Whatever the different methods are there, I will explain those. So you can create a simple stack using stack class or the list reference also. Using push method, you can push the elements into it. You can use for displaying the elements, you can use only the name of that stack, or normal for loop for each method, for each loop, while loop, anything, whatever you want. Okay, there are multiple ways which we have already seen. Then pop method is used for removing the element which is the top of the stack. So when the data goes into the particular stack, whatever the top of the stack will be removed. So when we are pushing these elements, so cherry will be the top of the stack because the apple goes at the bottom. Then the pineapple will go. Then guava will be on the top of that, and then the cherry will be on the top of that. So in our case, cherry is the top of the stack. So whenever you are using this pop operation, first element, that is the top of the stack, gets removed and or popped, and remaining stack will be untouched or kept as it is. Okay. So this is all about stack. So other than these two methods, there are few more methods of the stack class, like pick. You can pick any element. That means instead of popping the element, you can only check which method is the top of the stack. So that is the pick method. That is defined in the stack class. Pop method removes the element. Pick method only check which is the top of the stack element. Okay. I will show you once the execution of this example. So you can see here, this is the popped element, that is cherry, they are top of the stack. These are displaying the remaining elements of the stack. Okay. And this is, which we have already seen, list related. Okay. Now we will go forward with the next part. That is the collections class. Java.util package have some utility class, which is collection frameworks class known as collections. Okay, there is a difference between this. It is a collection framework. Collection is interface and collections is a class. Okay, don't get confused. Collections is a class, is the one of the utility classes in Java collection framework. Defined in java.util package itself. Collection class is basically used with static methods to operate on the collection and return the collection. Okay, whatever the collection utility classes are, utility methods are there in the collections class that we will see. So basically, it has some methods for operating following operations, like adding element, sorting any collection, researching in a collection, copying elements, finding the disjoint collection, etc. By default, ArrayList does not sort any members in any order. In any order, basically. So collections class provide by this Java collection framework to manipulate the members of our collection. So if we want to rearrange the members of our array list, we can make the help of collections class methods, that is sort method, and we can sort our collection. Okay, any collection. Mostly we use this for list itself. Okay, collections class is a singleton class. We have already seen what is the singleton pattern is. That means it has a private constructor. You cannot create object of this collections class directly using the new keyword. All the methods in collection class are static, and we can call them by using the class name. So we'll quickly see how to sort the elements. So suppose this is the array list which we have created yesterday. This is our array list, and I want to sort it. So you need to simply use collections. You need to import the collections class, use a sort method, pass this list. That's it. Okay, so your list will be sorted. List is L. Okay, and after sorting, you can see this same collection. I'm displaying this again after sort. So all the sorting will happen in the same part. Okay, same collection. It will rearrange the elements after sort. Executing this. So this is your list after sort. The two numbers are there first, then the X and then B. Okay. So because B is added later, that's why it is showing this after sort. So this is the list after sort. You can see this in this way. So you can use the collections.sort method, which is the static method used for sorting array list. Okay, this always takes the list reference. We never use sort method on any other data structure. Then if you want to sort the data which is stored as objects, you can create the collection of objects also. Then we need to use any of these interfaces. First one is the comparator, second one is the comparable interface, which will be used for comparing the objects based on different criteria. And then based on different criteria, you can compare and then you can sort the elements stored into the list. So in the comparable interface is used to sort the objects with natural ordering. Comparable interface compares this reference with the object specified. Comparable is present in java.lang package. Comparable affects the original class, that is the actual class is modified. Comparable provides compare to method to sort the elements. Second one is comparator. Comparator is a functional interface basically. Comparator has a single abstract method, that is compare method. Okay, comparator is Java used to sort attributes of different objects, different attributes. Consider this statement. Okay, it will sort attributes of different objects, and this directly compares the objects. Okay, comparator in Java compares two different class objects provided. A comparator is present in java.util package. These are two in the different packages. Comparator doesn't affect the original class. Comparator provides compare method, equals method with to sort the elements. Now we will see one example. I have already created that example. So first we will see the collections class example. So collections class has the methods. First I have created this array list. Okay. The first method we have seen the sort method, which is used for sorting any list. Okay. After sort, here you can use another reference also. That is, we can provide the list, and if you want to sort that in the descending order, any list into descending order, you can use the reverse order method, so that the current list will be sorted into descending order. Normally, sort method sorts the collection into ascending order. Okay. So there is another list which is holding the string data. We are using sort method. Then the reverse method is also used to reverse this list. We can reverse it. It will give you the mirror image of in the form of original arrangement. Okay. Then there is a shuffle method. All these are static methods, so you always have to call these using collections name. Okay. Then the shuffle method will randomly rearrange the members from your list, okay, from your given list. Then the swap method is there. Swap, as the name suggests, we can swap the elements present at particular indexes. So it takes three parameters. First one is the list name. Second one is the index 1 and index 2, which you need to swap the values. Okay. So it will be, this indexes should be present in your list. It basically swaps the data, and it only possible based on the indexes. That's why we use the swap method on list itself. Add all method, which is a you can add other collections elements into any other collection, okay, or different methods, multiple methods into this current collection also. So add all method is collections class method. Add all method there is in the collection interface also. Okay, those are different methods. So here when we use add all method, in the given collection you can add more than one element at a time, because using add method we can add only a single element at a time, single object, but using add all method you can add multiple elements at a time. You just have to give the values comma separated. You can give any type of values according to your given collection. Then there is a copy method which is used for copying the particular list data to another list data. That is a destination list you have to provide and source list from which you want to copy the elements into another one. Here the main thing is, when it copies, the operation is based on indexes. Okay, so the index of each copied element in the destination list will be identical to its index in the source list. So whatever the data present at the given index should be the same, or it will be stored at the same index in the destination list. So destination list must be at least as long as the source list. So if you are saying that your source list is of 20 size and your destination list is having less values, then you're copying the element, you can do that. Okay, because the remaining indexes will be there present, or in the destination list, if you have a 20 elements and you are trying to copy the data from the same source list to destination list, then it will be difficult to copy, because it is longer, and in remaining elements in the destination list are unaffected. Okay, other elements will be unaffected. Only the elements which you are adding from the source list to destination list, copying, those elements will be affected. Those indexes will be affected, basically, nothing else. Okay. Then the last one is rotate method. Rotate method is basically you can rotate the elements stored into this list. So how to rotate? So you have to provide the current collection and the distance by how many numbers you want to shift the elements. So it will rotate it. That means it is shifting the elements. Okay. You need to give the distance. So suppose you are giving 2 indexes, then every 2 indexes it will be shifted. The values will be shifted by 2 indexes. Okay. The members who are left are shifting will be given place from the start index onwards. Okay. So here I am using 3 index, 3 numbers. We'll execute this. So you can see this is before sort. After sort, we are getting the collection value, that is the list value. ascending order sorted. This is the descending order sorted. So this is happening in the same collection. Okay, in the same collection. It is not changing anything, or it is not returning any another collection. It will be using the same collection, same list to store the sorted data, or all these operations should be on the same list. Okay, then this is the data, string data, which is also sorted using alphabetical order. If you are reversing it, so you can see whatever the data you are sorted, it will only get reversed. It will not give you the descending order. Okay, it will only give you whatever the current collection elements are, that will be in the reverse order after reverse. Okay, then shuffle. We have shuffled the elements. It will be automatically rearranged, the elements automatically it will take. Okay, swapping I have done. So for swap, I have given 4 and 1 index. Okay, so the fourth index is this 62 and 1 index is 48. So you can see 62 and 48. So 5 will be shifted here, and this is shifted later. Okay, so this is how this 75 and 5 is swapped. Then add all. I have added these 3 elements at a time using add all method. Copying the name list. So I am copying the to list data, the names from name list. From this, I am adding to the fruit list. So you can see from third one, 2 values are present in my fruit list. So from third index, the data gets copied till the end of the elements. Okay, so other elements are unaffected. Whatever the elements we have already in our name list, that is 2 elements, are as it is, and from third index it is started copying from the source list. Okay. Last one is the rotate method, where I have given the 3 as the value. So you can see we have rotated by 3 indexes. So the 1 will become the first element, 62, 75, and then the next elements will be rotated by the indexes. This is how the collections class utility methods work. Then, as we have seen, the comparator and comparable. So comparator interface is used in this way. As it is a functional interface, you can implement it. You need to provide the type of object you want to compare. That is the object name, that is class name, student, which we have already seen how to create the student class. Okay, so it has a compare method, which is used for comparing different attributes of the student class. So here you can, as it is an functional interface, you can give the implementation to this. Instead of creating a separate class, you can use anonymous inner class, lambda expressions also. But here I am using a separate class just to show you. So this compare method, if the 2 objects are equal, it will return 0. If the first one is greater than second one, it will give you the value less than the other one. If it is greater than the other one, it will give you less than 0 value. Okay, so we need to compare these 2 objects. As we have seen, it compares 2 different objects. So it is comparing student S1 and student S2 object, and we want to compare these based on roll numbers. Okay, that's why I am using here returning s1.getRoll number and s2.getRoll number. Here, instead of this roll numbers, you can use names also. If you are using names, you need to use string method, compare method also, to compare the strings, and you can return the value as it is. Okay, string comparison. You can compare student object based on any attributes, any member of that class, like using this comparator. Okay, so if you use the comparator, it will be easy to compare the objects based on different type of elements. So to see the example, I have already created 5 student data, created one array list with these student elements, student objects. So you can save these student objects directly here using the add method. Okay, then to sort the elements or these student objects based on comparator class, we can use the sort method in the collections class itself. It takes the list reference and the comparator class reference as a parameter, so that it will compare the two objects from the list and it will sort the elements based on the given list. Okay. So here we are using collections.sort student list, which we have created. And here I am creating the object of compare roll number class, which we are created here, which is implementing comparator. Okay. So you can, instead of this, you can directly create a anonymous inner class here and write the compare method. You can write lambda expression also. You can pass anything, whichever you want. And after sort, the student list will be changed and it will be sorted based on roll number ascending order. Okay. So we'll execute this. So you can see before sort, this is our student list. Roll number 12, 14, 18, 19, and 11. Okay. Now after sort, you can see it is sorted in ascending order properly. So 11 is at the first, then 12, 14, 18, and 19. If you are sorting based on name, then it will get sorted based on names. It will never changes the roll number part. According to the name part, it will change the roll number itself. So that means Amisha, if we are saying that Amisha should be the first, so AM, it will be first, AN will be next. So 12, 14, in this way we will get the values. Okay. If you are comparing the elements based on name. So in the comparator, it is the main advantage that you can compare it based on any attribute of this any class. Okay. Whatever you want to sort, you can compare it based on any attribute. This is important because in the priority queue also we are going to use this comparator. Okay. This is the one way comparator. Second one is the comparable. So in the comparable, as we have seen that it will affect the original class. That means whenever you are creating any Pojo class, in the same class, you need to implement the comparable interface and give the type as the same class name so that it will compare the current object of this person class with the given object. Okay. Any other object. So here in the same class, we are implementing comparable interface. Here in this class, we need to provide implementation to this compare to method, and we need to generate the hash code method also. So to generate the hash code method, we use source hash code and equals method. Okay. And generate it. Okay. It will be automatically generated when hash code is generated by the system so that it will be easier to understand, and it is a normal integer value. Okay. So remember this hash code part because it will be used in the sets and HashMap also, HashSet and HashMap also internally. So this is the equals method where we are comparing two objects of the person class itself. In a similar way, in the compare to method, we will be providing the implementation to the compare to method. In the we need to provide how to compare these two objects, that you need to first consider. So I'm going to compare these two objects based on person ID. I want to sort the elements based on person ID. So here I'm going to use if current objects this dot person ID equal to O dot person ID, I'm returning 0. Okay. Else if these two are equal, then it will return 0. If any of these is greater 1, that means this dot person ID is greater than O dot person ID, then we need to return 1, that is a greater than 0 value. Okay. And else if nothing is greater, then we are returning -1 value. Okay. So here okay, this is the compare to method we are implementing. So whenever you are creating objects in a same manner like this. If you are creating objects of, instead of this student, you are creating the person class object and creating the array list of that particular person objects and using the sort method directly. You can use the sort method and remove this part, and the data will be sorted automatically by using this compare to method. It will compare the person IDs stored into that list. It will internally use this compare to method and get automatically sorted based on person IDs. Okay, you don't have to write separately anything. So here, whenever you want to use the comparable, you must use it with this pocho class itself in the same class. Okay, so this is the difference between comparator and comparable. These two are used for comparing different objects. If you want to sort it, you need to use these two compulsory. Any of these two compulsory. Okay. Next one is the queue interface. So queue interface maintains FIFO order. FIFO order means first in, first out. It is the order similar to real world queue line. We have already seen the real-time example also. Okay. The order of the elements matter. There are various implementation classes. Mostly we used are priority queue and array DQ. Priority queue is used when the objects are supposed to be processed based on natural priority or natural ordering of the numbers, or you can provide the comparator so that you will construct a queue based on the comparator provided. Okay, so comparator you can provide when you want to store the objects of different types instead of primitive types. If you want to store any objects of different types, then you can use this comparator. You can provide the comparator. Otherwise, the data will be sorted into or stored into natural ordering. Okay. So depending on which constructor is used. So this is a queue interface. So first we will see how to create the priority queue reference. This is a priority queue default constructor. Here, the initial capacity of the priority queue is 11. Internally, it uses array itself. All this data structure uses array itself, but those arrays are changing. Grows and shrinks internally. You don't have to use any other, or you don't have to do it externally. It will automatically be grown and shrinking as per the need. Okay, so here we are creating queue reference, priority queue, adding any elements. So we already seen the collection interface add method. Apart from that, we have offer method in the queue interface, which is used for adding the element. Okay, so everything is same. Element method is there and get method is there in the list interface. Element method is there in the queue interface, which will just retrieve the head of the queue, whatever the element. So it maintains the last in first out order. Okay, so sorry, FIFO order, first in first out. So whatever the data was first should be removed first. So 56 will be going into the queue first, so it will be removed first. So the head of the element will become 56 itself, and it will be getting, if you want to retrieve it, you can use this element method. Pick is also used for the same. Pick method is there in the stack also. So pick is also returning the head element of the queue. Poll method is used for polling, that is removing the element apart from the remove methods, which we have seen. Apart from the remove methods, queue interface has poll method also, which will remove the head of the your queue. Okay. This is all about priority queue. Other methods are same. Size method is there, capacity method is there. You can search it. You can use contains method. All these methods which we have seen in the collection interface, all those methods are there here in the queue interface also. Okay, so everything is same. Only the data structure changes and few more methods are added in every data structure. Next one is the array DQ implementation. Array DQ implementation is the DQ interface implementation class. Okay, so DQ interface is also known as double-ended queue. We can perform the operations from two ends, both the ends. That means from front end and the end also. Okay, so head and tail, we say it as head and tail. So here we are creating array DQ reference. We can insert the elements based on different ways. So add method we have already seen. Offer method also we have already seen. So if we want to store the data or we want to perform the operations from tail end, we can use offer last method and add last method also. If you want to store from the head part, then we can use add first, offer first, and push methods to insert the elements. Okay, so these methods work from the head of the DQ, and these methods work on the tail of the DQ. So basically it performs the same operations, inserting, updating, deleting, but only the difference is we can perform it by using two ends, from the front end, that is head end, and tail end also. So from both the end you can add the elements. So here we are creating any element. In the queue we never add the null element. Null element is not added into the queue because it is a null. It throws the null pointer exception. In list we can add the null element any number of time. Okay, any number of time you can add the null element. It is never going to cause any problem because duplicate elements are also allowed. But in the queue it uses we never uses the null because it throws the null pointer exception. So we cannot add any null value into queue. Okay, you can add any other elements and you can display these elements based on whatever the methods we have seen, like for each method, for loop, for each loop, or iterator, anything. So if you want to see these elements, you can see it using system.out.println ArrayDQ. ArrayDQ elements, you can use only reference also. Okay, we will get the values as it is. Okay, this is the values get stored. Okay, so this is how the head of the element is 12. Head of the element of the queue using pick is also 12. Pole, that means head of the element gets removed. Okay, so for removing the element from this ArrayDQ, you can use remove methods, and there are methods like remove last, then pole last, remove first, pole first, and pop method. Okay, all these methods are used for removing the elements. Based on these, same as these all methods works on the first and last end, similarly you can remove the elements also using these same methods like pole first, pole last, remove first, remove last. Okay, and with the push you can use pop operation, that is of the stack. Okay, this is all about queue interface. Any doubt till here? Okay, so this is the DQ interface. This is a very slight variation in the queue data structure. DQ means known as double-ended queue, is the data structure where we can add and remove elements from both the ends of the queue, known as head and tail. Since the ArrayDQ class is the implementation for the DQ interface, we can instantiate it using the queue interface name or directly the object, creating the object of ArrayDQ class direct. Okay, so it is a resizable array. As the name suggests, it uses the array. Okay, so it is the implemented in the collection framework, which provides you dynamic array or resizable array. Internally, it grows and shrinks and performs the operations based on indexes directly. You don't have to worry about it. It will be done internally by the collection framework DQ interface ArrayDQ class itself. You just need to use it and save the data using the collection interface methods. As it is a parent interface, you can use those methods everywhere. Okay, this is all about DQ interface and queue interface, queue data structure. Now we are going to see the next data structure is set data structure, where we are going to save the data, which is a unique way, in the unique way. Okay, so we'll create one class, set example, including the main method. So I'm creating a set of type integer. Okay, set of type integer is equals to new. Now there are two implementation classes, HashSet and linked HashSet and TreeSet. Okay, so any of these you can use. implementation classes to store it. So I am going to first show you the HashSet, new HashSet. So HashSet uses internally HashMap data structure. So you can see this is a HashMap data structure. It stores whatever the data we are going to store into this set. That will become int set dot add. I'm adding some value that will be stored as a key into the map. Okay, key into the map. So suppose we are creating any map. I will show you how to create the map also. Map. There are two parts. First one is the key part and second one is the value part. So you have to mention with what type of keys you are going to store and what type of values you are going to store. So there will be two types. So first I am going to store integer as the key and string as value. And we are initializing it through HashMap class. There are HashMap and TreeMap classes, linked HashMap also. These are also into the util package. Okay, these, when you want to store the data into map, instead of, as this is not a part of collection interface, there are multiple different methods to store the data. Using put method, we will store the data into it in the form of key and value. So suppose key is the one value is suppose, okay, in this way you can save the elements into map. But when you are putting the elements into map, key should be unique. Values can be anything, whatever you want, but keys should be unique. Duplicate keys are never stored into the map. Okay, values can be repeated, values can be duplicate, that is fine, but keys should be unique. Okay, here you can store the null also, but you cannot give null as a key. You can give the null as a key also, but only once. That is, duplicates are not allowed in the key part, so it will give you problem. Okay, so here for the first, this statement will give you problem, and then we will get this problem. Okay, so if you want to iterate over it, then we don't have a iterator for the map. If you want to iterate over it, we have a method, map elements. First we have to use for iterate over collection. We have to use first map dot entry set. Okay, this entry set method returns you the entry set reference, that is a set reference, okay, which has the entry for the key and value. And then on this entry set, we will iterate over it based on this entry set. Okay, so we can now iterate over this collection that is on the set using iterator. Okay, and it returns this. So from the map, you can retrieve the key and value separately. So system.out.println entry dot get key is the method which returns the key part, and the second one is entry dot get value is the method which returns the value part. Okay, I will execute this. So you can see we are getting null, one null, two null, three null. Sorry, okay, the three values, duplicate values are there, but the whatever the values we have try to set in a duplicate way, that will be omitted. Okay, so it is not going to give you any exception, but it will be omitted. It will never save it, because HashMap and HashSet uses internally hash code mechanism. It calculates the hash. If the hash is same for the given key value, if the HashSet, if hashing code is same for the given keys, then it will skip that part, or it will assign the same in the linking part. Okay, so that's why HashSet internally uses HashMap structure. In this way, you can add any numbers. So in the set, we cannot store the duplicate values because of the same reason that we have just seen. that it never stores the data duplicate keys value. Okay. You can store null only once. You cannot store multiple times. If you try to store null into this, it will give you problems. Okay. So we will see the values. Set is equals to interset reference I am displaying. Okay, these are your set references, set values. So you can see we are only getting 4 values from this much values. Why? Because 52 is duplicate value, null is duplicate, 520 is also duplicate. So only once it will be added, because the hash code for these values will be same. When we are trying to add, it will calculate the hash code, and if the hash code is same, it will never add that value into the set again. Okay, that's why it only stores the unique elements. This is all about set. Okay, this is a hash set. Another one is tree set. Linked hash set is similar to the linked list, but tree set is little bit different. So we can create the tree set reference. Tree set, I'm specifying type as double. Okay. Tree is equals to new tree set. Okay. Now when you are adding any data into the tree set using add method, then this data will be sorted automatically by its natural ordering. Okay, it will get sorted and stored into the tree set automatically because it uses comparator internally, and data will be sorted automatically based on the given values. Okay, so I'm giving some values here, and we will display the tree set. System.out.println tree set references tree here. So you can see the tree set which we have created, the values are stored in the natural ordering. So basically it is a tree like a structure. This will be the root node, maybe this is its child node, or you can say branch node. So as I said, it is using the binary tree structure. So the root node will have a left hand side will be the lesser value, right hand side will be the greater value. So always it will use the same thing. So this is the data stored into the tree like a structure, and it is always uses natural ordering of its sorting. When you want to sort or when you want to store the objects like this student, person, etc., you need to provide the comparator like this, or the comparable, or that class should implement the comparable so that it will use those comparators and or comparable in part and compare the objects based on the given type and save the data into the tree set. So if you want already sorted data should be there, you can go for the tree set. Or if you just want to store the data which is unique way and it never stores the duplicate data, then you can go for the hash set. Okay, other elements for removing is empty, clear, iterator, everything is same. You can go through it later also. Okay, all these methods are same. Only the difference between the set data structure is in the tree set also it only stores same elements. It will never store duplicate elements. It will only store unique elements. Okay, so this is how the set data structure works. The difference between hash set and tree set is only that hash set internally works based on the hashing algorithms, or you can say hash codes, and tree set is used for storing the data into natural ordering by default. Okay, so you, as per the need of your application, you can select any of these. These things are there into the map. So map, if you are using HashMap, it also uses internally hashing part, And it is also using the hashing part. It creates the hash code and it uses that. So there is a lot of things like load factor and all. You don't have to go through it more. Okay, this is a compulsory internal working of HashMap, which uses hash tables basically. Okay, hash tables is based on the hash codes, and it uses some buckets, some initial capacity, some load factor to generate that hash table. Data gets stored into the hash table. It always calculates when the hash table is about 75% is full. Again, the hash calculation is done and it will be growing your memory for storing the next elements. Okay, so internally it uses buckets concept. Okay, you can go through it if you want, that is not required. So this is HashMap, and same, it uses hashing part for storing the data. That's why map never stores the duplicate keys, but duplicate values are allowed. You can store n number of data into it. It always gets stored into key and value pair. In a similar way, we can store the data into TreeMap. Okay, so there is a TreeMap which is again used to store the data in the natural ordering of elements. Okay, here also you can, instead of the in the value pair, instead of the string and primitive types, you can use objects also. You can store objects also. Okay, like student object, person object, any other objects you want. To iterate over this, as this is not a part of collection framework, or you can say collection interface, it is not a direct child of collection. We need to use entry set method to retrieve the entry set, and then we can iterate over that entry set using the methods get key and get value. Okay, clear? Any doubt? Anyone? So this, with this, our collection framework is completed, and this will be the last session of your class. So if you have any doubts or any other concerns, you can directly contact to the Stu Valley coordinator. Whoever will be the coordinator of you can directly contact to the Stu Valley coordinator. And if you have any technical doubts, you can always go, you can ask them. They will tell me. I will.
This is the last class of the entire training?
Yes. From the core,
Okay.
it is the last
Only
one.
core Java things are getting covered, I think, right?
Yes.
Till now?
Core Java, this is the last one.
Okay. So again, Spring framework and other things are there.
It is in the advanced part. So if you are admitted for the same, then we will be conducting the advanced part. I don't have the knowledge about it. So you should connect to the Stu Valley coordinator. They will guide you accordingly.
Okay.
Okay, so this is still here. We are completed the core Java part. So current batch is for the core Java. I think so. If you are upgrading for the advanced one, then we will be conducting the sessions later when it will be scheduled.
Okay. Okay.
Okay.
Yeah.
Any other technical doubts? The remaining modules, PDFs, I will be sharing in few days. Okay. The only collection framework part is remaining from my side. So I will be completing it and I will share the remaining modules from my side within some days on your WhatsApp itself, WhatsApp group itself. Okay. So if you have any technical doubts, if you have any doubts in complete syllabus, you can always ask. First, you can go, you need to connect to the Stu Valley coordinator and then they will tell me, I will guide you accordingly. Okay. Any other doubts, anyone? Okay, then all the best.
Yeah. Thank you, ma'am. Thank you very much.
Okay. Ma'am, I have already completed the session. So you may end the session. Thank you, everyone, and all the best for your future. You may leave. Ma'am, are you there?